I'll give you time to solve the question as we always do, then we'll discuss it together. Okay. So let me give you the first question. Can you see my screen?
Yeah.
So the first question is based on your percentage purity, question number 40. That a 5 gram sample of impure magnesium carbonate, it will react with an excess of hydrochloric acid, and the reaction stoichiometry, everything is given to you. 1250 centimeter cube of carbon dioxide is collected at RTP, room temperature and pressure. How many moles of CO2 are produced? Okay. So you have to use the formula and then use the stoichiometry of the reaction. What mass of pure calcium carbonate would give this volume of carbon dioxide, and calculate the percentage purity of this 5 gram sample. Try to solve it and we'll discuss it together. Okay, so first of all, you have to calculate in A part that how many moles of carbon dioxide are produced. Okay, so you will use this formula, number of moles is equal to volume upon molar volume, right?
Mhm.
Okay, so you know that molar volume, it is your 24 at room temperature and pressure, 24 decimeter cube at room temperature and pressure, right? So you have to convert this centimeter cube into decimeter. How? You should know this conversion, that 1 decimeter cube is equal to 1000 centimeter cube. So 1250 centimeter cube is equal to 1250 upon 1000, which is equal to 1.25 decimeter. Now you just have to substitute it in the formula. Number of moles is equal to volume upon molar volume, which is 24. After you solve it, you get the answer as 0.0521. Are you getting the same answer?
Yeah, I'm done.
What is the answer of B part?
I got 4.37.
Yes, 4.37 gram is the mass of pure calcium carbonate. Because how you have approached this? Because if the number of moles is 0.05 to 1 mole for carbon dioxide, then you know that 1 mole of magnesium carbonate, it is producing 1 mole of carbon dioxide. So number of moles of magnesium carbonate is also same, that is 0.05 to 1. And you know how to convert mole into mass. So you got the answer as 4.37 gram, which is correct. Now what is the percentage purity you are getting?
I got 87.36%.
Yes, because you have to apply the formula mass of pure substance, which is your 4.87 divided by mass of impure substance, which is 5 gram into 100. Okay. Now solve this question number 12. Hydrocarbons A and B both contain 85.7% carbon. Their molar masses are 42 and 84 gram respectively. Which elements does a hydrocarbon contain? Calculate the empirical formula and the molecular formula.
Okay.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So after 10th of June, you are not continuing with Keddy?
Yeah,
Okay, so this is your last class with me.
I think so.
Okay.
Done.
So which element does the hydrocarbon contain?
It contains carbon and hydrogen.
Yes. Calculate the empirical formula of A and B.
The empirical formula is CH2.
Yes. Molecular formula?
For A, it's C3H6, and for B, it's C6H12.
Yes, very. Molecular formula is C3H6 for A and for B it is C6H12. Okay, it's also done. Now, solve question number 10. 110 gram of manganese was extracted from 174 gram of manganese oxide. What mass of oxygen is there in 174 grams of manganese oxide? How many moles of oxygen atoms is this? How many moles of magnesium atoms are there in 110 gram of manganese? Empirical formula, and then what mass of manganese can be obtained from 1000 grams of manganese oxide?
Done.
Yeah. So the question is that 110 gram of manganese was extracted from 174 gram of manganese oxide. So what mass of oxygen is there in 174 gram of manganese oxide?
64 grams of
Yes.
oxygen.
Yes, because a manganese oxide mass minus of manganese gives you 64 grams. Okay. How many moles of oxygen atom is this?
The 4 moles.
Yes, number of moles is equal to given mass upon molar mass, which is equal to 4. How many moles of manganese atoms are there in 110 gram of manganese?
The 2.
Yes, given mass upon molar mass of manganese is equal to 2 moles. Give the empirical formula of manganese oxide.
It's MnO2.
Yes, it is MnO2. So you have to see the ratio of mole of oxygen, the ratio of mole of manganese atoms. It is 4:1. In the simplest form, 2:1. So you have MnO2 as the empirical formula. What mass of manganese can obtain from 1000 grams of manganese oxide?
132.18.
Pardon?
632 grams of manganese.
Yes, 600. Yes, because you have to, what you have to do, you have to do the mass of manganese, you have to calculate the mass of manganese in 1000 gram of manganese oxide. So you have to take the mass ratio of manganese, which is 110, to the manganese oxide, which is here 174 given in the question, multiplied by 1000, which gives you 632.18 grams. Okay, very good. Now, solve question number. We have done this type. Solve question number 4. Nitrogen monoxide reacts with oxygen like this. Reaction is given, stoichiometry is given. How many moles of oxygen molecules react with 1 mole of nitrogen monoxide molecule? Easy. Then what volume of oxygen will react with 50 centimeter cube of nitrogen monoxide? Using the volumes in B part, what is the total volume of the two reactants and the volume of nitrogen dioxide formed? Solve it.
Done.
Okay, so let us solve. So the first question, it is that how many moles of oxygen molecules react with 1 mole of nitrogen monoxide molecule? So this is your balanced chemical equation. 2 nitrogen monoxide reacts with oxygen to get 2 NO2, right? So how many moles of oxygen molecules react with 1 mole of nitrogen monoxide?
0.5 mole.
Yes, 0.5 moles, because you can see the here stoichiometry. If 2 mole of nitrogen monoxide is reacting with 1 mole of oxygen, so 1 mole of nitrogen monoxide will react with half mole of oxygen. Right. B part. What volume of oxygen will react with 50 centimeter cube of nitrogen monoxide?
25 centimeter cube.
Yes, it is 25 centimeter cube, because as you know that 2 mole of nitrogen monoxide is reacting with 1 volume. So 50 centimeter cube of nitrogen monoxide, it will react with half of it, just the half of it, that is 25 centimeter cube. Next is using the total volume using the volume in B, that is 25 centimeter cube. What is the total volume of the two reactants?
It's 75 centimeter cube.
50 plus 25 is 75 centimeter cube. And the volume of nitrogen dioxide form?
It's 50 centimeters cubed.
50 centimeter. Because from the balanced chemical equation, 2 volume of nitrogen monoxide, it produces 2 volumes of nitrogen dioxide. Therefore, 50 centimeter cube of nitrogen monoxide will produce 50 centimeter cube of nitrogen dioxide. Okay. Solve question number 9 also. Zinc and phosphorus react to give zinc phosphide. 9.75 gram of zinc combines with 3.1 grams of phosphorus. Find the empirical formula for the compound and calculate the percentage of phosphorus in it. Let me just bring it down.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done.
Okay. Find the empirical formula for the compound. What you are getting the empirical formula as?
It's ZN3E2.
Okay. And percentage of phosphorus in it?
24.12.
Yes, 24.12%. Okay. So this is very easy question. You have to do like this only. So for finding the empirical formula, divide this mass with the molar mass, then divide this mass of phosphorus with this molar mass. Then just take the simplest, divide it by the smallest number, take the simplest ratio, and you get the empirical formula. Now to calculate the percentage of phosphorus in it, first of all you have to calculate the mass of phosphorus in ZnCP2. Then you can easily calculate it by mass of phosphorus divided by total mass of the compound multiplied by. Any doubt in this type of question?
No.
Give you another question. Solve question number 7. You have to prepare some 2 molar solutions with 10 gram of solute in each. What volume of solution will you prepare for each solute below? First is your lithium sulfate. Second is your magnesium sulfate, and third is your ammonia. You wrote this formula, right? That concentration is equal to number of moles by volume.
Yeah.
You have to calculate volume, concentration is given, number of moles you have to calculate using the given mass of solute divided by molar mass. So solve A and B part only, C part you can do. So what is the volume
Should
for
I
the, yes, what is the volume for the lithium sulfate?
should I give it in dm cubed or in centimeter cubed?
The answer is coming out in decimeter cube. Otherwise, you have to convert it into centimeter cube. It is not written in the question that you have to convert. Because you know now that 1 liter is equal to 1 decimeter cube. So answer
Okay,
it in decimeter cube.
so I got 0.0455 decimeter cubed.
Yes. Decimeter cube or liter. Second part.
For the second part, I got 0.6625.
0.65.
625.
625. Just a minute. For magnesium sulfate, what is the molar mass you are getting? For the magnesium
got-
sulfate?
Oh, for the magnesium sulfate, I got 0.091.
No, I'm asking the molar mass of magnesium sulfate.
Molar mass is 110.
No. Magnesium is
Oh.
24.
Oh, magnesium 25 it's 120.
Yes, 120. Then number of moles is equal to given mass upon molar mass, which comes out to be 0.0833, and then you have to do it by divided by 2. So the answer is coming out as 0.04165. Okay, so correct it. 0.04165 liter or decimeter. Now take a screenshot of question number 8. Practice this at your home. Otherwise, all the questions we have done.
Could you scroll a bit down?